Okay, so we are talking about 4.3, solving rational equations and inequalities. So today we're going to do sections, or examples 1, 2, 3, and 4. We will save 5, 6, and 7, which are kind of the application ones, for next class. So if I look at this kind of definition up here, before we're solving these rational equations, which just means anything with that fraction, so something like this or something like that below, we have to identify what values would be undefined. So things like that make wholes, or things that make the denominator equal to 0, right? Those are like our possible vertical asymptotes if we were graphing it, or it's our wholes if we're graphing it on our graphing calculator or by hand, okay? So we always have to omit those solutions. And another thing I just want to note up here is that we are finding all complex solutions. Okay, when I say finding complex solutions, what do you think I mean by that?
Square roots.
Yep, square roots could be part of it. That would be also, so like square roots of what do you mean? Just square roots?
All other roots.
All other roots. So like, yeah, like if I had like the square root of 7 or something like that. Or if I had, what about like the square root of -7? That would also be a complex solution, right? Because I would have an I in there too, right? So we're going to also maybe have some imaginary solutions in here, but that is part of our finding our complex solutions, okay? And then our first step when we are solving these rational functions or inequalities is to multiply each side of our equation or inequality by the least common denominator, okay? So if I look at this first example here, I've got x plus 2 divided by 2x plus 1 equals 1. Could I just cross multiply here in this case? Like if I put this over 1, you guys have seen a problem like this before in algebra for sure, right? We could just cross multiply and do it like that. Okay, I'm going to show you the least common denominator way because that's how we're going to do the rest of these, just to give you some more practice and to expose you a little bit more, okay? But first thing we have to do is, what can x not equal, okay? Do I have any wholes that are going to cancel out on the top and bottom? No, so I don't have to worry about any of those. However, I do need to worry about when does 2x plus 1 equal 0. I can't have that, I can't have 0 in the denominator, right? So I got to solve this here. When is x, or sorry, what value of x is going to make this 0? -1/2, okay? So I cannot have x equal -1/2. If I do in my final solution, we're going to have to omit that answer because it's not part of our solution, okay? Our least common denominator. Least common denominator means I'm looking at all of the denominators that I have in my rational fraction or rational equation, and I am multiplying the entire thing by that least common denominator so that I can get rid of all my denominators, okay? So the only thing in the denominator in this problem is what? 2x plus 1, right? So my least common denominator is just going to be 2x plus 1. And the way I like to write it is I just like to write it in front of all of the things in the equation so that I know I have to multiply everything by that 2x plus 1. It's not just the left side, right? It's an equality statement, so everything has to be the same on both sides. Okay, but when I am distributing this to my first fraction there, 2x plus 1 times that fraction, I'm going to be left with just x plus 1, or sorry, x plus 2. Because that 2x plus 1 will simplify to be 1, right? And then what am I going to have on the right side when I distribute the 1 to the 1? 2x plus 1. Which, this is exactly what I would have gotten if I just cross-multiplied right up here. Okay, so again, for this example, you could have cross-multiplied. For the examples we're going to do here soon, you will see there is more than one fraction, so you can't just cross-multiply them, okay? So let's just do some little algebra here. Get my x's on one side. If I subtract this x over, I'm going to be left with x, and then I can subtract the 1 over, so x equals 1. And that's your answer. For that one, yes. Okay. Now, did I get x equals 1/2 in my answer there? No, so I don't need to omit anything. So you're done with this answer right here. You might see answers written like this, This is just a fancy way of writing the same exact thing, except that's supposed to be a curly bracket there. Okay? That's another way of saying the exact same thing as x equals 1, but it's written, this is called set notation. Okay, so you might see some answers written like that, either like on homework or in your future math classes, so just kind of exposing you to a little bit of that. Okay. Let's look at example number 2. Example number 2. I've got 3 fractions here. So what I would like you to do real quick is to find what x cannot equal. Okay? Look and see, are there any holes, or what makes the denominator equal to 0? Okay, go ahead and solve for those. When I solve all 3 of those equations, what are the 2 numbers that x cannot equal? 2 and -2, so you can write this as plus or minus 2. You can write it as plus 2, -2, however you want to write it. Okay, so that's there. If we get one of those answers, we will have to omit them. So now let's look at the least common denominator. Before we do that, how do I factor x squared minus 4? Difference of squares, right? So x plus 2, x minus 2. So what would my least common denominator be? I need to get rid of all of those fractions. Yeah, x plus 2 and x minus 2, right? Least common denominator, x plus 2, x minus 2. Okay, so you can kind of write this one of 2 ways, however it works for you, as long as you are remembering to multiply this by every single thing. I like to write it like this on the outside of my entire equation, but I realize, that's not everyone's vibe. So if instead you would like to just write next to the equation what you need to multiply by, that's fine too. So like right here, I've got a denominator of x minus 2, so I need to multiply the numerator by x plus 2, right? This next one, I've got x plus 2, which means it would simplify out with this one here, and I would just need to multiply this by x minus 2, right? And then for that last one, since I have x plus 2 and x minus 2 in the denominator, I wouldn't need to multiply by anything. Well, I technically multiply by the whole thing of x plus 2 and x minus 2, but it ends up simplifying with the denominator, okay? So however you want to write it, if you want to write it like this, if you want to write it like the whole equation, either one works. So like if I multiply here, this x plus 2, x minus 2 with this first fraction, right? The x minus 2s are going to simplify out, right? They're going to simplify to be 0, or 1, sorry. And then all I'm left with is x times x plus 2. You agree? Okay, so same thing up here. If I multiplied this x times x plus 2, I would get the same thing. Okay, because that x minus 2 is simplifying out with that least common denominator that we're multiplying by. Okay, then if I multiply this entire quantity here with my second fraction, those x plus 2s are going to simplify to be 1 this time, and I'm just going to be left with x minus 2. And always be careful, because sometimes that sign might be a negative, so I would always put it in parentheses. Okay, and the last one, I'm multiplying the entire least common denominator with the other side of my equation, so I'm just going to be left with 8, because that x squared minus 4 is going to cancel out or simplify to be 1 with that least common denominator. Okay, so now we just got an algebra problem here. We just got to distribute, and then I think we're going to have to actually factor. Okay, so if I simplify on the left side, I get x squared plus 2x plus x minus 2. Combine all my like terms. And what does it have to be equal to in order to factor? 0. So I'm going to move everything over to one side. So I've got x squared plus 3x minus 2, but then I'm subtracting 8 over here. So I'd actually have minus 10, right? Okay, hopefully we remember factoring. However you want to factor, if you want to do factor by grouping, This one is nice because your a value is 1, so you can do the shortcut. Or if you do guess and check, whatever works for you. Okay, I'm going to fill out my cross product sum puzzle here with -10 and 3. So we're thinking what multiplies to give us -10, adds to give us 3. 5 and -2, yes. There you go, 5 and -2. And since that a value is 1, I can go straight to my answer of x plus 5, x minus 2, and that equals 0. Okay, but we're solving an equation right now, so I need to get, I need to figure out what my x is actually going to equal, right? So zero product property says I can set x plus 5 equal to 0 and solve, and x minus 2 equal to 0 and solve. And when I do, I get x equals -5 and x equals 2. So these are both of my solutions. However, which one do we have to omit because of above? Yes, we have to omit x equals 2 because of this given fact up here that x cannot equal 2, okay? So your answer for this entire equation right here, this whole entire rational function, is equal to 5. Okay, let's step it up a little bit. We're going to have to do some factoring by grouping, and this one will actually give us some imaginary solutions as well, okay? So, example 3. Instead of dealing with negative exponents, is there another way that I could write this without negative exponents?
1 over x to the 4th.
Yes, exactly. So I'm going to rewrite this as 1 over x to the 4th minus, if I rewrite 5x to the -2nd, does 5 also go down to the denominator? No. So 5 is going to stay on top, and then I've got x squared in the denominator minus 36. Okay, now it's a little bit easier to see. First thing we got to look at is what can x not equal? This one's a pretty easy one. X cannot equal 0, right? So if we get 0 in our final answer, we will have to omit that. Now we got to see what is my least common denominator between all of these. What do I have to multiply the entire equation by in order to get rid of all of my denominators?
X squared.
X to the 2nd would not get rid of this x to the 4th, right? So I got to get rid of x to the 4th. How am I going to get rid of x to the 4th? What? Multiply by x squared would leave me with an x squared in the denominator.
Multiply by x to the 4th.
If I multiply by x to the 4th, would I get rid of that? Yeah, did someone say that over there? I'm sorry. I couldn't hear. I thought you said x to the 2nd. You guys gotta be louder. Okay. So we're gonna multiply by x to the 4th, the entire thing. Okay, when I multiply that first fraction there, I get 1. Because those x to the 4ths simplify to give me 1, sorry. X to the 4th times my second fraction is going to leave that 5 on the top, but what am I going to have with that 5 actually?
X squared.
X squared. Because I've got 2 exponents down here, that's going to simplify with 2 exponents out of that and leave me with x squared. And then the last one, pretty easy there. Multiply x to the 4th times -36, I get -36x to the 4th. Okay, let's rewrite this in decreasing order of degree or in standard form, so that way it's easier for us to see how we're going to factor this. Okay, so I'm going to rewrite this -36x to the 4th minus 5x squared plus 1. This is all equal to 0. You guys know how to factor this? Yeah, we know how to factor this. There could be one other thing that we could do before we start factoring it to make it a little easier for us. I don't like it when that a value is negative. So I'm going to take it out. I'm going to divide all those numbers by -1. You don't have to necessarily do that. I just think you'll make less mistakes if you do it that way. So that's what we're going to do. Am I going to be able to use a shortcut here? No, because our a value is not 1. So I'm going to go ahead and create my x product sum puzzle. I've got negative 36 in the numerator, 5 in the denominator. What's going to be my two numbers that multiply to give me that and add to give me 5? 9 and 4. And the 4 would be negative. Okay, so remember we are taking these numbers now and replacing that 5x squared because we've got to do factoring by grouping because a is not 1. So I'm going to rewrite this 36x to the 4th plus 9x to the 2nd, right? Minus 4x to the 2nd minus 1. And technically, what am I missing in front of all that? The negative 1, right? Okay, do we remember how to factor by grouping? Yes, go ahead and do that right now for me, please. I'm going to start showing my work up here. If you are struggling, pay attention to what I'm doing. So what we do need to do is set 9x minus 1 equal to 0 and 4x squared plus 1 equal to 0. I need to see when is x going to make those equations true. All right, these are both quick two-step equations. I'm solving the left one here. I get 9x squared equals 1. Which means x squared equals 1 over 9, which means if I take the square root of both sides, what is x going to equal? 1/3. Is it just 1/3? Plus or minus 1/3, right? When I've got an equation and I take the square root, I do need two answers there. Okay, so that is one of our answers. Do we need to omit anything from those, from what we were given above? Nope, we don't. So now I just need to go ahead and solve the other one there. So I get 4x squared equals negative 1, which means x squared equals negative 1/4. So now when I take the square root of both sides here, what am I going to get for my answer?
1/2 I.
Yeah, 1/2 I, plus or minus, right? So if you forgot, right, I is the square root of negative 1. So we can think about rewriting this one, right, as the square root of 1/4 times the square root of negative 1, which would give us that 1/2 I. Okay? So those are both of our answers. We don't need to omit anything because 0 is the only thing that it could not be. So we are done with that one. Is there any questions? Okay, so now we have an inequality, okay? Anytime we've got an inequality, your first step is going to be to make sure that it is equal, not equal, but whatever the symbol is, make it so that 0 is on one side, okay? So get 0 on one side. Okay? So I'm going to go ahead here first and subtract that 1 over. So I'm going to have x plus 2 divided by 2x plus 1 minus 1 is less than or equal to 0. Okay, the difference between inequality and an equation is that instead of having 1 or 2 or 3 answers, we're going to have a range of values that work for x that make this inequality true, right? But we still do have to figure out when are there holes or when is x going to make the denominator equal to 0. So am I going to have any holes in this inequality? No. Okay, they can't cancel out with any numerator and denominator. However, I can have 2x plus 1 equal to 0, and when does that happen? When does x equal? Or what does x equal at that point? Negative 1/2. Okay, so x cannot equal 1/2. So if we find that as an answer, we will have to omit it, okay? So we got to look at what is my least common denominator out of all of these things. The only one that's got a fraction, I got to get rid of that denominator. So what am I going to multiply the entire inequality by? 2x plus 1. Okay, so when I multiply it by that first fraction, those 2x plus 1 simplify to be 1, right? And I'm left with just x plus 2. Now, here's where people make mistakes, because this next one, there is a negative in front of that 1. So when I distribute this, make sure you plug it in parentheses, otherwise you will get the wrong answer, okay? And then on the right side, I'm still going to have 0. Okay, so let's go ahead and distribute that negative, do a little bit of algebra, combine I like terms. So I'm going to get negative 2x minus 1. And then I'm left with negative x plus 1 is less than or equal to 0. Okay? And then if I want to solve for x, easiest way to do it, I would say, is to add the x over. So that way I don't have to worry about, remember what happens when I divide by a negative for inequalities? You got to flip the sign, right? So you could technically subtract the 1 and then divide by negative 1, but that's just like a whole other step that you don't need to do, okay? So I've got my answer here, but we're not done, okay? We need to test our points. We need to make a number line, test some values, because we do need to account for this negative 1/2. Yes, it's not a solution. However, it splits up our graph into 3 intervals. So what do I mean by that? I mean that if I have an interval here, I'm going to put any whole or any value that x cannot be and the answer that I got, okay? So for this example, I would put negative 1/2 and 1. Okay, those are the 2 values that I either could not have or that I got for my answer. Okay, now at 1/2 or negative 1/2, we cannot have that equal to it. So I'm going to have an open circle, right? That's why we have an open circle at negative 1/2. But now at 1, x could be greater than or equal to 1, right? So what kind of circle am I going to have at 1? It's going to be a closed circle, right? Okay, so now I need to see on what intervals do x make this inequality true. So I need to test some values, okay? So I'm going to test a point in between all 3 of these values. And I'm going to plug it back in. You can either plug it back into the original, or it might be quicker or easier if you plug it into the one that's less than or equal to 0. Up to you. But we're deciding if it's true or false. Is it making the inequality true when you plug it in, or is it making it false when you plug it in? Okay? If it's making it true, that's part of our solution. If it's making it false, it is not part of our solution. So let's start in the middle here. What's a number in between negative 1 and 1 that I could, or sorry, negative 1/2 and 1 that I could plug in easily? 0. Okay, so I'm testing 0. I want at the bare minimum to see the number that you tested. Okay? You do not need to show all the work of how you plug in the 0. I am going to, since we're going through this right now. But on your quiz, test, that kind of stuff, I don't need to see this. Okay? I'm going to plug in 0 into this inequality right here. So when I plug in 0, I get 0 plus 2 divided by 2 times 0, which is 0, plus 1, and then minus 1. Is this less than or equal to 0? That's what we need to see. 2 divided by 1, that's 2. 2 minus 1 is 1. Is 1 less than or equal to 0? No. All right, so above this one, we're going to say false. Okay? No value in between negative 1/2 and 1 are going to make that inequality true. You could also put an x if you want to put an x instead. Okay, so that interval is not true for my inequality. Oops. Okay, let's test a point to the right of 1. What's an easy point that we could plug to the right of 1? 2. If I plug in 2, okay, again, plug it into either one of those, you should get the same thing. I'm going to plug it into the one that has 0 on the left or on the right side. So I've got 2 plus 2 divided by 4 plus 1 minus 1. Is that less than or equal to 0? Well, let's finish evaluating it. I got 4 on top, 5 on bottom. So 4/5 minus 1. That would give me negative 1/5, right? Is that less than or equal to 0? Yes. So this would be true. So that means that any value that I pick on the right side of 1 to plug in for x, it is going to make that inequality true. Okay, so we're going to have to write that as a interval here in a minute after we check on the left of negative 1/2. Easy point to plug in on the left of negative 1/2. Negative 1, okay? So I'm plugging in negative 1 into my inequality. So you're going to have negative 1 plus 2 divided by negative 2 plus 1. Okay, well, if I simplify that, negative 1 plus 2, that gives me 1 divided by negative 2 plus 1, which is negative 1. So I get negative 1 minus 1, which would be negative 2. Is negative 2 less than or equal to 0? Yes, so this part is true on the left-hand side. So check mark there, or true, whichever one. Okay, so I know that on the intervals to the left of 1/2 and to the right of 1, no matter what x value I plug into my inequality, it's going to make that inequality true. Okay, so for our answer, we need to write this as an interval. Okay, so if I'm doing the left chunk there, it'd be from negative infinity to negative 1/2. However, I can't have negative 1/2 included, so I'm going to use a parentheses, right? But then I am including 1, so what am I going to have around 1? A bracket. So bracket from 1 to infinity. So as long as your x value lies in between those two intervals for this inequality, it would make it true. Okay, a little note that I want you guys to put on here as well, because remember this negative 1/2 and this 1 I got from whether or not there were holes or vertical asymptotes, that kind of stuff. So I want you guys to write yourselves a little note that you have to find the zeros for the numerator and the denominator. Okay, so that's how we got our 1/2 from what our denominator could not equal 0, and we got 1 by solving it there. So, got to test those things on our number line in order to get our intervals.